Good afternoon. Last class, I discussed to you expansion devices. By that expansion, pressure and amount is reduced to the evaporator for easy evaporation. Today, my topic is evaporator. So, in refrigeration and air conditioning, evaporator is a important part for producing cooling. So in refrigeration field, we need cooling. From evaporator, we get cooling. So evaporator is a part of refrigeration and air conditioning cycle. So it is located after expansion device. Now we can see a small refrigeration cycle. See, normally the refrigeration cycle consists of compressor, condenser, then receiver, expansion device, then evaporator. So this is today our part evaporator. Here we are getting cooling. After expansion, the low pressure gas entering into the evaporator coil. Here the low pressure, low amount liquid refrigerant is entering. Then this low pressure, low amount liquid refrigerant absorb heat from the refrigerated space. In refrigerated space, heat is available. It is from air or substance. Then it absorb, the evaporator coil absorb sensible as well as latent heat from the surrounding space, and this liquid change to vapor and surrounding space is to be cooled. So that is the function of evaporator. So in evaporator, the low pressure, low amount liquid refrigerant absorb heat from the refrigerated space, and refrigerated space is to be cooled. So that is the function of evaporator. So we can discuss about what is evaporator and what are the types of evaporator. Then explain the construction and working of evaporator. What is frosting and defrosting? Explain the defrosting methods. These are the topics we can cover today. So a small example I am showing to you. So here a sponge and some liquid will be there. This sponge is absorbing this liquid, and this liquid is vanishing. Like in evaporator, the low pressure liquid refrigerant is passing. The low pressure liquid refrigerant absorb heat from the surrounding space, and surrounding space to be cooled. See, when liquid is vaporizing, when liquid is evaporating, at that time it produces a cooling effect. For that purpose, we are using low pressure, low temperature liquid is supplying to the coil with the help of expansion device and other related components. So this is a small example shown here, how the sponge is absorbing liquid. Like that, the evaporator is absorbing heat from surrounding space, and surrounding space to be cool. Then the evaporator become cold. Due to evaporation, it is cold, and again remain cold due to some conditions. The conditions are the temperature of the evaporator coil is low due to low temperature of the refrigerant inside the coil. In evaporator coil, the low pressure refrigerant is passing. By that, low pressure liquid refrigerant absorb heat from surrounding space, and surrounding space to be cooled. By that, evaporator coil is producing low temperature. Then the low temperature of the refrigerant remain unchanged. The temperature is produced, the low temperature of the refrigerant remain unchanged because any heat is absorbed is converted to latent heat as boiling proceeds. That means in evaporator, the two types of heat will be there. One is sensible heat and another is latent heat. Latent heat means change of state, liquid change to vapor. When liquid change to vapor, it produces a cooling. Then in evaporator, we know some other names that are cooling coil, chiller, freezer. These are the other names of evaporator. Evaporator is also known as cooling coil, chiller, or freezer. In evaporator, both latent heat and sensibility of the air or substance in the referred space is to be absorbed. So, in referred space having a sensibility, for example, a refrigerator, when we are inserting some products, that means fruits or vegetables, items are bringing outside to inside. So, at that time, that rises the temperature, that is sensible heat. For example, 30 will change to 31, 32, 33. Afterwards, it will coming down also. 32 will change to 30, 28, 27, like that. It is coming down also. Simultaneously, the heat it absorbs latent heat. Latent heat means change of state. The liquid change to vapor state. By that time, what happened? It will produce cooling. So, evaporator absorb sensible as well as latent heat from the refrigerated space and produce cooling. Now we have to study about the capacity. Evaporator required a capacity. Okay, the definition is the capacity of an evaporator is defined as the amount of heat absorbed by it over a given period of time. The heat absorbed or heat transfer capacity of an evaporator is given by. That means Q is equal to U into A into temperature difference. Temperature difference means T2 minus T1, and it is expressed in watts or joule per second, where U means overall heat transfer coefficient in watts per meter square degree centigrade. So U is, what is U? U means heat transfer. Simply we can tell U is heat transfer. How we can express it? Is expressed in watts per meter square degree centigrade. A means area. Evaporator having a area. Area means L into B. Okay. So evaporator having a surface area will be there. That is expressed in meter square. So first we have to take heat transfer coefficient. Then we have to measure the evaporator area L into B in meter square. Then temperature difference. Temperature difference means T2 minus T1. T2 means temperature of medium to be cooled. That means outside of the evaporator. So evaporator having a temperature and surrounding having a temperature. That means space or food materials or air. That is T2. Then T1 means evaporator temperature. T1 means evaporator temperature. Evaporator temperature means saturation temperature of reference at evaporator pressure. From evaporator pressure, that means the liquid changes to vapor. In evaporator, the liquid changes to vapor state. At that time, one temperature is producing in evaporator coil. That is T1. So we have to take T2 minus T1. Evaporator temperature is low and surrounding temperature is high. Surrounding means inside of the cabinet. So that two difference we have to take it. So T2 minus T1, that means temperature difference. Evaporator coil temperature and the space temperature inside of the cabinet. That is T2 minus T1. Then the first we have to take the overall heat transfer coefficient and surface. By that together we will get in watts or joule per second. That is known as evaporator capacity. Evaporator capacity means the capacity of an evaporator is defined as the amount of heat absorbed by it over a given period of time. The heat absorbed or heat transfer capacity of an evaporator is given by Q is equal to U into A into temperature difference. That means T2 minus T1. Here it is expressed in watts or joule per second. Now we can go for types of evaporators. There are different types of evaporators used in refrigeration and air conditioning. One is based on concession, then based on function. Like that, it is classified. First classification is based on according to the concession. Concession base. By the concession base, the evaporators are common evaporators. The different types of evaporators will be there. Concession base. Some common are explained here: bare tube type evaporator, finned type evaporator, plate type evaporator. Some other model also will be there. Plate and tube type also will be there. Plate type will be there and plate and tube type also will be there. At that time, I will explain you. Then shell and tube type evaporator, shell and coil type evaporator, tube in tube type evaporator. That means it is similar to condenser. Condenser also some wire mesh type plate type is coming. Similar type this evaporator also coming. So here I am explaining this type evaporators, bare tube type evaporator, finned type evaporator, plate type evaporator, shell and tube type evaporator, shell and coil type evaporator. Next tube in tube evaporator. First we can go for bare tube type evaporator coil. This is a simple sketch of a bare tube type. That means it is a simply we can tell it is a this is expansion valve. After expansion, evaporator coil is going. This is a continuous tube coil. It is a continuous tube coil and generally used in small applications. And outlet is connected to the suction line. And its use is limited under 0 degrees centigrade and in liquid cooling, because accumulation of ice or frost on this evaporator has less effect on the heat transfer than other those equipped with the fins. And this bare tube evaporator comprises of several turns of tubing. So these are the tubings. These tubings are in different shapes like flat, zigzag, and oval trombone are the most common shapes, and these tubes are made up of in steel and ammonia. We are using steel pipe. So it is a in bare tube type coil evaporator only a continuous tube coil. One end is connected to the expansion valve and other end is connected to the compressor. That means suction side. This is a simple type bare tube coil evaporator. Another is finned type evaporator. Generally, this type evaporator we are using in window type air conditioner and split air conditioner. Then in visible coolers evaporator side we are using frost free refrigerator. We are using fin type evaporator. In concession, it has a tube. This is a tube coil, continuous tube coil, and it is covered with the fins. In this type evaporator coil, a fan is necessarily required and it is located behind the evaporator coil for proper air circulation. And this tube having an inlet and outlet. One inlet is required and another outlet is there. After expansion, the liquid refrigerant enters into the inlet and flows through these tube coils. In this time, the fan forces the air over the coil. The fan is taking warm air from the rougher space and passing over this coil. So when this warm air is passing over this coil, the evaporator coil absorbs heat from air and air is to be cooled. The cold air is circulated with the help of fan. So this type a fan is required, and generally this fins type evaporator application we are seen from air conditioning. That means above 0 degree centigrade system. That is high temperature system. In high temperature systems, we are using fins type evaporator. So this is known as fin type evaporator. Another is plate type evaporator. There are in this two model will be there. Plate type evaporator will be there, and another is plate and tube type will be there. The main difference is these two are generally using small systems like refrigerator. Like that area we are using. See here, a plate will be there. Between this plate, channels or grooves are provided through that grooves or channel referent is passing and having a plate. This is the plate. What is the function of plate? Plate is used to increase the surface area for clear air contact with the help of this plate. And this plate is generally made up of aluminium. Okay, so aluminium having better heat transfer capacity, then having an inlet and outlet. See, this is inlet. Suppose this is inlet and this is outlet. And inside plates, between these plates, channels or grooves are providing. Through that channels or grooves, a referent is passing. Finally, through this way, it is coming out. This is a plate evaporator. Plate and tube means first having a plate. Above the plate, a tube coil is fixed on the plate. That is known as plate and tube type. Plate type means there is no extra tubes between the plates. Channels are or grooves are provided. That is plate type. Both are small difference. Plate type means a plate. In that plate having itself grooves or channels. Through that channels or grooves, referent is passing. That is known as plate type evaporator. Plate and tube type means first having a plate. Above the plate, the tube coil is fixed. That is known as plate and tube type. These two type evaporators generally we are using in small systems. Okay, so mainly having a inlet, outlet and plate. After expansion, the low pressure liquid referent enters into the inlet and pass through the several channels. By that, the referent is spreading and absorb heat from surrounding space, and surrounding space is to be cooled. After evaporation, vapor referent flows to the compressor suction. This is the working of plate type evaporator or similar to the plate and tube type evaporator. Next is shell and tube evaporator. It is also known as chiller, and this type evaporators or chillers used in large system. Generally, it is using in air conditioning systems. So it is the reverse of shell and tube type condenser. You already learned shell and tube type condenser. This is the reverse, shell and tube type evaporator. So we can see first having a shell. This is a shell. Outer having a shell, violet color showing a shell, and having a liquid in, liquid out. Liquid in and liquid out means secondary referent. Here it is coming a secondary referent. Second referent is coming in and the second referent going out. Here we can consider secondary referent is water. In air conditioning, we are using water as secondary referent. So here liquid in means water. I said secondary referent and coming in, and this is going out. When it is going out, it is chilled. Chilled means near about, suppose water entering is 20 degrees centigrade and going out is 6 degree centigrade. And bottom liquid referent in. Here referent in. Inlet of the evaporator coil, a expansion valve is provided. Here the expansion valve is thermostatic expansion valve. That also last class we are explained about thermostatic expansion valve, its construction and working. So here the expansion device is thermostatic expansion valve. So in shell and tube type evaporator, the refrigerant inlet having a thermostatic expansion valve, and this is outlet. Outlet means vapor referent out. So vapor referent to compressor. So here liquid referent in, and this is liquid vapor refrigerant out, and that is going to compressor. So this is the second referent in, second referent out. That means chilled liquid out. And here having a buffers. So these are buffers for diverting or directing the secondary reference. Now we can see the working. After expansion, the low pressure liquid refrigerant flows through this tube. See, through this tube, the refrigerant is passing. Like this, it is a refrigerant. Through tubes, refrigerant is passing. Low pressure liquid is passing through these tubes. Okay, so in tubes, refrigerant is passing. Above the tube or shell, secondary refrigerant is coming. So, example, here second refrigerant is water. The second refrigerant temperature is 27 degrees centigrade. That is entering here. And see, by these buffers, it is going like this. So, first it is reached here. Like this, it is passing. See, by this arrow, it is moving like this. And finally, it is coming out. Now, chilled. Finally, the second refrigerant is to be chilled. This 27 degrees centigrade will change to 6 degree. Example, one example I am telling. Okay, so 27 degrees centigrade, second refrigerant is chilled to 6 degree centigrade. This 6 degree centigrade chilled water is supplying to AHU or some other purpose for cooling. So this is the construction of shell and tube type evaporator. Once again, I am repeating. So it have a shell. This is a shell. That's why it is called shell. Then this is called tube. Then so tube. So shell and tube evaporator. One having a shell, another having a tube. Okay. Through tubes, refrigerant is passing, and over the tubes or inside of the shell, second refrigerant is passing. Both are passing in opposite direction. Okay, and this evaporator inlet having a expansion valve. That expansion valve is thermostatic expansion valve, and this is outlet. That means vapor from the out, it is going to compressor. Okay, so when warm second refrigerant enters into the evaporator coil and passing through it, then the primary refrigerant absorb heat from secondary, and second refrigerant is to be chilled, and this chilled liquid is sending to some other AHU or some other purpose for cooling. This is the construction and working of shell and tube type evaporator. And another one model also will be there, shell and coil type. Previously we are explained the tube. Now instead of tube, coil. Both are almost similar. That tube is parallel. Now this here, the tube is a coil type. So first having a shell, this is a shell, and having a coil. Okay. So the refrigerant here, liquid refrigerant in and refrigerant out. That means primary. So this is primary refrigerant in and out, and this is secondary water. Water means secondary. Secondary refrigerant in and second refrigerant out, and this is known as coil, and this outer is known as shell or tank shell. Okay, so first having a shell, inside having a coil. Through that coil, primary refrigerant is going. So that primary refrigerant have a inlet and outlet. Through inlet, which is coming, liquid refrigerant is coming. Outlet, which is going out, vapor refrigerant is going out. So here, second refrigerant is coming. Second refrigerant enters into the tank. Then what happened? This primary refrigerant absorb heat from secondary, and secondary is to be chilled. The chilled secondary refrigerant going out, and it is going to AHU or some other purpose for cooling. This is the shell and coil type evaporator construction and working, and it generally used in small capacity. That means we are selecting 2 to 10 ton capacity, and its cooling is maintained up to 5 degrees centigrade, because below 5 degree or below 4 degree or just below come to 0 degree, it will be freeze. Then it is difficult. When water will freeze at 0 degree, then what happened? It will be struck. So above 5 degrees centigrade system and 2 to 10 ton capacity systems, we are preferring a shell and coil type evaporator. So it is a type of evaporator. and generally used dry expansion evaporator. This is a common dry type chillers. And another is a tube in tube evaporator or tube within tube type evaporator. Already in condenser side we are learned in tube within tube type condenser. It is similar type, two tubes. One tube is inserted to the another tube. Okay, and this is outer tube, and this red color showing a secondary referent. Okay, so primary referent, secondary referent. So primary referent in, that is referent in, and primary referent out. When primary referent going out, it is vapor state. Okay, and this is secondary referent. Second referent in. So through center of this tube, secondary referent is going, and finally it is going out. When finally it is coming out, it will be chilled, cold liquid. Okay, so after expansion, the referent in, it is passing through like this in downward direction, and secondary referent moving upward direction. In this time, heat transmission is happening, and primary referent absorb heat from secondary, and second referent is to be chilled. In this way, we can cool the items. So generally, these types are used for wine cooling or in petroleum industry for chilling of oil. So like any second referent we have to cool, we can use primary also by this way. Here secondary, we can tell wine. Wine is the secondary, or oil is the secondary. For chilling oil or chilling wine, okay, we can use this type of evaporator. In this way, we can cool the wine or cool the oil. By this method, we can cool. So this is another method of cooling, and this model is known as tube in tube type evaporator. Then next we can go another type according to manner in which liquid refrigerant is fed. So in evaporator we are feeding refrigerant. By feeding refrigerant, there are two types of evaporators. One is flooded type evaporator, another is dry type evaporator. Okay, so by feeding of refrigerant to the evaporator coil, the evaporator coil is classified into two types: flooded type evaporator and dry type evaporator. Flooded type means, see by the name itself, flooded means the evaporator coil is filled with full of liquid. That is the meaning of flooded. Dry means not dry, not 100% dry. It is only a small quantity of refrigerant. That is the meaning of dry here. Okay. So in flooded means evaporator coil, you know evaporator coil, it is a round tube. In that round tube, flooded means that tube coil is filled with full of liquid. 100% liquid will be there. In dry type, that means 1/4 in that tube coil, 1/4 portion having a liquid. That's why we are calling dry type evaporator. So this is the model of flooded type evaporator. This flooded type evaporator, first having a float valve will be there. This is the float mechanism. So full parts are here. Liquid refrigerant from receiver is entering, and here a float valve control will be there. Already by last class we are explained float valve controls, low side float valve and high side float valve. In that time we are clearly explained low side float valve. Okay, so this is the float valve, and this is the float, that means ball. Okay, and this is float chamber. Then having a evaporator coil. This is known as a evaporator coil, and here full of liquid refrigerant. See, full of liquid refrigerant, and this liquid refrigerant go into evaporator coil, and this evaporator coil absorb heat from air or substance, and substance or air is to be cooled. Finally, this liquid changes to vapor. So here mixer, last coil having a mixer, liquid vapor mixer. This liquid vapor mixer again reach to this chamber. Okay, here it is separating. liquid is going down and vapor is going up. Why? Liquid having more gravity. Due to gravity, the liquid is going down and vapor is less in weight. By that, vapor is moving up. So this having a suction line. Suction line is connected to compressor. When compressor is sucking, what is the function of compressor? The function of compressor is suck the gas from evaporator. Evaporator means from here itself it is sucking. So vapor is moving up. Okay, vapor is moving up, and here unvaporized liquid will collect in the bottom. See, in refrigeration cycle, we already explained one part will be there, accumulator. After evaporator coil, a accumulator will be there. What is the function of accumulator? Accumulator is used to collect the unvaporized liquid coming from evaporator. See, here no need of accumulator. This chamber will act as accumulator. That's why it is mentioned this is a accumulator. So this part we can tell as a accumulator also. So in this flooded type evaporator, no need of extra accumulator. This chamber will act as a accumulator. The function of accumulator is to collect the unvaporized liquid coming from evaporator. This is the flooded type evaporator construction and working. Once again I am repeating, this is referent liquor referent from receiver. That means first compressor will be there, then condenser will be there, then receiver will be there. After receiver, the liquid is coming to this chamber entering. Okay, here having a float valve with the float mechanism will be there. Here we can call float chamber, and evaporator coil is fixed on this body. Okay, then this liquid referent enters into this accumulator part. Then this evaporator coil is full of liquid refrigerant, and this liquid absorb heat from surrounding, and surrounding space is to be cooled. Then here liquid and vapor back to this chamber or accumulator. Here both are separating. Liquid and vapor are separating. Vapor is going to compressor and liquid is collecting in accumulator. Then what is the function of buffle? Here one buffle is provided. The function of this buffle is to prevent the flow of liquid, liquid particles from this bottom to top. So this is preventing. Buffle is used to preventing the liquid particles. It allows only vapor to flow to compressor. This is the construction of working of flooded evaporator. Another is dry type evaporator. This is the sketch of dry type. The dry expansion evaporator are not really dry at all. Already I told dry means not dry. Okay, here dry means a small quantity of liquid. Flooded means the 100% of liquid in evaporator coil. Here evaporator coil having 100% liquid refrigerant. But here only after expansion a 1/4 in tube having 1/4 portions only, or half, less than half portion only liquid is passing. That's why it is called a dry type evaporator. And comparing flooded type and dry type, flooded type is a large capacity type evaporator and dry type is a small type capacity. For our example, refrigerator having a evaporator that by construction base we can tell plate type or plate and tube type in ordinary type refrigerators. In that is dry type evaporator. Only a small, after expansion, a small quantity of refrigerant is going to the evaporator. They simply use relatively little refrigerant as compared to flooded evaporators having the same coil volume. Suppose both flooded type having a particular evaporator coil volume will be there. Here dry type evaporator having a particular quantity volume will be there. But here a small quantity of refrigerant is flowing. But in flooded 100% liquid is flowing. The dry expansion evaporators are usually only 1/4 filled with liquid. Already I am explained only 1/4 liquid refrigerant is passing, and a simple bare tube dry expansion figure is showing in this. and finned coil dry expansion evaporator is also available. And just I am telling the working. See, this is the expansion valve. Which type expansion valve? Thermostatic expansion valve. So, and here roughened inlet, and this is roughened outlet. Outlet having a feeler bulb is clamped. So after expansion, the low pressure liquid refrigerant is passing through this evaporator coil, and this evaporator coil absorb heat from roughed space, and roughed space should be cooled. Then vapor refrigerant. Vapor refrigerant means this is highly superheated vapor, 100% vapor. Okay. Occasionally, a small quantity of liquid refrigerant also will be coming. If it is coming like that, it will collect in the accumulator. Normally, vapor, the superheated vapor refrigerant goes to compressor. This is the working of a dry type evaporator. Then another type of evaporator in this field is natural convection evaporator and forced convection evaporator. What is natural convection evaporator? The natural convection evaporators are used where low air velocity and minimum hydration of the product is desired. The domestic refrigerator, water coolers, and small freezers have natural convection evaporator. Okay. Forced means in forced convection evaporator, the air is forced over the evaporator coils and fins. This is done by a fan driven by an electric motor. The fins are provided to increase the heat transfer rate. So, heat transition method, by the mode of heat transition method, the evaporator is classified into two types: natural convection evaporator and another is forced convection evaporator. Natural means, example, refrigerator. Refrigerator evaporator is natural convection type. Then another example for forced convection, split air conditioner. Split air conditioner, the evaporator is which type of forced convection. Another example, window air conditioner. In window air conditioner, the evaporator is fins and tube type evaporator. In fins and tube type evaporator, a fan is also provided. That is known as forced convection. That means the air is transferring with the help of a forced method by using a fan. Natural convection means without fan, by natural movement of air, the air is passing. On that base, by heat transition method, the evaporator is divided into two types: natural convection and forced convection. Natural convection evaporators are used widely low air velocity. Sorry, because by natural air it is passing, but fan is there. With the help of fan, the air velocity will be higher. That's the one another main difference. So natural air velocity is low, and forced convection air velocity will be more. Then another is according to operating conditions of evaporator temperature. So evaporator, based on operating conditions, the evaporator is again classified into three types: frosting type evaporator, defrosting type evaporator, and non-frosting type evaporator. Okay, so operating condition based evaporator is divided into three types: frosting, defrosting, and non-frosting. What is frosting? Frosting means evaporator coil has more frost. Why? Because its temperature is below 0 degree centigrade. That's why we are called frosting type evaporator. Example, refrigerator. Refrigerator evaporator is a frosting type evaporator. Why? Because its temperature is below 0 degree centigrade. Then another is defrosting type evaporator. Defrosting type evaporator also have more frost because its temperature is also below 0 degree centigrade. Example, refrigerator. Refrigerator evaporator temperature is below 0 degree, and your refrigerator also more frost accumulated in the evaporator coil. That evaporator also we are calling defrosting type evaporator, because once frost is accumulated, we have to defrost with the help of defrosting methods. Another is non-frosting type evaporator. Non-frosting type evaporator, by the name itself, non-frosting, that means no frost. Because why? Its temperature is above 0 degree centigrade. Its temperature is above 0 degree centigrade. There is no frost accumulated in the evaporator. Example, air conditioner evaporators or split air conditioner evaporator, there is a non-frosting type evaporator, and there is no frost accumulated in the evaporator because its temperature is above 0 degree. So with the help of operating condition or temperature, the evaporator is classified into 3 types: frosting type evaporator, defrosting type evaporator, and non-frosting type evaporator. Frosting and defrosting both are below 0 degrees centigrade, and non-frosting is above 0 degree centigrade. Then cooling method. On the base of cooling method, again the evaporator is classified into direct cooling and indirect cooling. Direct cooling means air cooling, and indirect cooling means liquid cooling. Direct cooling means the evaporator coil cool the air or food substance directly by absorbing latent heat. That is known as direct cooling. Example, our refrigerator. Refrigerator is an example of direct cooling, and a split air conditioner, that evaporator is also an example of direct cooling. Directly absorbing heat from air or food substance. That is known as direct cooling. Indirect cooling means, example, simply directly I am going to example ice plant. So in ice plant, evaporator coil will be there, then a drain solution will be there. First, evaporator coil absorb heat from drain solution. Okay, then drain solution is to be cooled. Then this drain solution cool the water for making ice. Okay, so there is a media between substance and evaporator coil. A media will be there. Okay, first evaporator coil cool the secondary roughen, then the second roughen further cools to air or food substance by absorbing their sensible heat. That is known as which type? Indirect cooling. So according to cooling method, the evaporator coil is divided into 2 types: direct cooling and indirect cooling. Then, so now what is evaporator? What are the types of evaporator? Evaporator construction and working is over. Now in evaporator having a frost, when cooling is happening and below 0 degree reaching, the frost is starting. Then why? The freezing point of water is 0 degree. So in low temperature system, we need -5, -10, -20. At that time, more frost accumulate in the evaporator. So now we can go for frosting and defrosting. So what is frosting? So accumulation of moisture present in evaporator is called frost. In evaporator coil, moisture is coating. When moisture is coating and change to ice, then we can call frost. Here 1/4 inch, more than 1/4 inch frost accumulate the evaporator. Frost act as heat insulator and reduce the heat transition. So evaporator coil will be there. Inside of evaporator coil refrigerant. Here outside frost is forming, and this frost will change to ice, and its thickness is more than 1/4 inch. At that time, it will work as a heat insulator. By that, heat transmission is reducing. Okay, so at that time, we have to remove this frost. That is known as defrosting. Removal of frost is known as defrosting. Okay, so the defrosting methods will be there. By proper methods, we have to defrost the system. The defrosting methods are: one is manual defrosting method, another is time shutdown defrosting method, another is pressure controlled defrosting method, temperature controlled defrosting method, water defrosting method, reverse cycle defrosting method, simple hot gas defrosting method, automatic hot gas defrosting method, electric defrosting method. These are the different defrosting methods. So what are the defrosting methods? Manual defrosting method, time shutdown defrosting method, pressure control defrosting method, temperature control defrosting method, water defrosting method, reverse cycle defrosting method, simple hot gas defrosting method, automatic hot gas defrosting method, and electric defrosting method. First we can go one by one. Manual defrosting method, first we can go. This is the manual defrosting method. This is a simple type of defrosting method. Example, in our refrigerator, there are 2 types of refrigerators will be there. No frost refrigerator will be there, and ordinary or conventional type refrigerator will be there. In that, in no frost, automatically it is defrosting. In manual defrosting, if you need defrost, there's a thermostat switch will be there. in that thermostat switch having a knob, in that center part having a red color. Here inside of the refrigerator, when you open the door, inside of the refrigerator having a defrost knob, and inside of the knob center having a red color button, that is known as defrost knob, push button defrost knob. You push that defrost knob. When you are pushing, what happened here? Contact point is open. Once the contact point is open, the compressor is off. When the compressor is off, the temperature is increasing inside of the cabinet and frost is melting. Okay, so that is known as which method? Manual defrosting method or simple defrosting method. So here your pushing is sufficient and it will automatically come back for starting. No need of pressing back. So this is the manual defrosting method or simple defrosting method. So you have to push it. In defrosting knob, here you have to push it. When you are pushing, the contact point is open. When contact point is open, compressor is off. After off, what happened? Inside the temperature is increasing. Once the temperature is increasing, the frost is melting. Okay. Then what happened? Then temperature is increasing. Here a feeler bulb will be there. The feeler bulb temperature is increasing. By that, volatile substance change to vapor state and bellow pressure will be increased. By that action of bellow pressure, it will automatically close, expand the bellow and close the contact points and start the compressor. In this the method. That means on and off method of the compressor. That means the compressor stop until frost is melted and start the compressor. Next is the time shutdown defrosting method. In time shutdown defrosting method, some components will be there. One is defrost heater and another is timer. The next you have to see compressor also will be there, fan. This four part you have to just remember it. Here in time shutdown defrosting method, this is the timer. This is the main part. This timer, after this timer depends upon different time settings will be there. 5-hour settings, 6-hour. Different company having different settings. This timer switch off this compressor and on the heater. When switching off the compressor, same time this fan also will be off. Okay. So one example I am telling now. After 5-hour duration, this timer switch off the compressor and fan and on the heater. Which heater? Defrost heater. This defrost heater just heat and frost will be melt. After 5 minutes, here cam will be there. After 5 minutes, automatically this heater will be off and compressor and fan will be on. Regularly, a particular interval, this defrost timer regularly defrosting the system. This is known as time shutdown defrosting method. By a time based, okay, by a regular time based, this timer switch off the compressor and fan and heat the defrosting heater. This defrost heater work 5 minutes. By that 5 minutes, it develop heat and frost is melting. Whatever the frost is accumulated in the evaporator coil, it is melting. Then after 5 minutes, this timer again switch off the heater and on the compressor and fan. By this method, frost is defrosting and automatically. That is known as time shutdown defrosting method. Another is pressure controlling defrosting method. This is used in large plants. So here a pressure controlling device will be there. Low pressure cutout. Okay, this is compressor and this is condenser, receiver, expansion valve, evaporator, suction line. In suction line, a pressure operating control will be there. That means LP cutout, low pressure cutout, and it is connected seriously to the electrical motor. Once temperature is come down, when evaporator temperature is come down, what happened? The pressure also will be come down. That means when temperature will come down, more frost accumulate in the evaporator. Then what happened? Here the pressure controlling device is not getting sufficient pressure. The pressure also will come down than the limit. For example, our suction pressure is 40 psi. By less than 40 psi, pressure is occurred in the low pressure cutout. At that time, it will cut off the system. Once they cut off the system, what happened inside here? Evaporator inside the temperature is increasing and frost is melting. By that, frost is melting with the help of a pressure control method. Okay, so this is pressure controlling defrosting method. In pressure controlling defrosting method, a pressure operating control device will be there. How this will work? When evaporator temperature decreases, what happened? The pressure also decreases. That means temperature is corresponding to pressure. Temperature increases, pressure increases. Temperature decreases, pressure decreases. Now the temperature is decreases. When temperature is decreases, what happened? More frost accumulate in the evaporator coil. At that time, what happened? Here suction pressure also reduces than the limit. Once the pressure is reducing than the limit, what happened? This pressure control switch off the system. Once the system is switched off, what happened? The evaporator temperature is increasing. By that increasing of temperature, the frost is melting. By this method, we can defrost. This is known as pressure control defrosting method. Another is temperature control defrosting method. This is the similar type of. Previously, by pressure it is switched off. Now by temperature it is switched off. That means now here we are connected a thermostat. Okay, compressor, condenser, receiver, expansion valve, evaporator, then compressor. This is the reference cycle. And here a thermostat. A thermostat means temperature control device. A thermostat will be there. Thermostat is connected seriously to the motor. Once temperature is come down, what happened? This thermostat switch off the system. When system is switched off, inside temperature is increasing. By increasing of temperature, the frost is melting. Okay, when after frost is melt, or when temperature is increasing, the feelable temperature also increased and this contact point is closed and start the system. By temperature method, it is defrosting. This is known as temperature control defrosting method. This is another method, water defrosting method or hot water defrosting method. Okay, so here you see the three pictures here. And here this is evaporator coil and this is fan. Okay, here a line, water line will be there and three-way valve will be there. And this three-way valve is operated in three positions. See, this is the one position, A position. This is in figure B, another position. This is straight. See, clearly you have to identify the figure here. This is the one position. This is another position. See, this is the third position. Okay. So in this method, when you need defrosting, at that time, in this is used in large system, the low side will make to pump down, and what happened? This valve will be opened. When this valve will be opened, water is spraying to the evaporator coil. When water means your water temperature is 25, 28, 30, like that temperature, or you can raise the temperature also with the help of heaters. So the water is spraying. Here frost means 0 degree. When this 30 degree water is spraying over the evaporator coil, what happened? The frost is melting and it will collect in the bottom and it is drained out. This is known as the water defrosting method. Simply we can tell, in ice is 0 degree. In 0 degree ice, a 30 degree water is spraying over the ice. What happened? The ice is melting. That means water is high temperature and ice is low temperature. Okay, like that in water defrosting method, when water is spraying over the evaporator coil, what happened? The frost is to be melted. This method is known as water defrosting method. Another is reverse cycle defrosting method. By this sketch, I am clearly explaining. See, now you identify the cycles. So, reverse cycle means, cycle is reversing. Okay, That means compressor will change as condenser and condenser will change as evaporator. That means when high pressure gas going to the evaporator, the frost can be melted. We can see by identifying these two pictures, we can see this figure. Okay, so by this figure here, after compression, refrigerant is going to condenser, then it is going to this way. Okay, through this expansion, then refrigerant is going to evaporator, then go back to compressor. This is the one cycle. This is the another cycle. See, now compression, it is going to evaporator. After compression, the refrigerant is going to evaporator. Okay, now the cycle is reversing. For reversing the cycle, a four-way valve is fixed. Four-way. This is the four-way valve. Okay, this is the normal cycle. Normal cycle means now compression. After compression, it is going to condenser. Okay, then what happened? And this is closed. Okay, then what happened? Through check valve, refrigerant is flowing, and through expansion valve, thermostatic expansion valve going to evaporate. This check valve also closed. Okay, this check valve is open and this check valve is closed, and this hand valve is also closed. So this is the normal cycle. Refrigerant is going to compressor. Okay, then when you need reverse cycling, what happened? You change, and evaporator will act as condenser and condenser will act as evaporator. Now we are changing by reversing this valve. What happened? The compressed gas is flowing like this. Now the high pressure, high temperature refrigerant enters into the evaporator coil. Okay, so what happened here? Frost is melt by reaching high pressure, high temperature. Okay, now the refrigerant is going through this. Through check valve it is going. Through here the refrigerant is passing. Okay, and what happened? And this also check valve is closed, and this is a hand expansion valve. Here it is opened. After expansion, here the pressure is reducing. Now this condenser will act as evaporator. Now this condenser will act as evaporator and going back to this compressor. Like this cycle is reversing. So a reverse cycle means the evaporator is changing to condenser and condenser will change to evaporator. And hot gas defrosting. This is a hot gas defrosting method. See, very firstly I am going to finish within time. So this is compressor and this is condenser, receiver, thermostatic expansion valve, evaporator and suction line. Okay, here a additional bypass line. Okay, that is known as hot gas line. Okay, in discharge line, a line is additionally fixed and connected between evaporator and expansion valve. Okay, and controlled by a manual. Okay, so normally it is closed. If you want defrost, open this valve. Then what happened? The compressed gas going to this evaporator and back to compressor. This time what happened? The frost is melting. After melting the frost, you can close the valve. Then normal cycle, and this compressed gas going to condenser, then receiver, then expansion valve, then it is going to evaporator. If it is going like this, here it is stopped. Okay, so this is the normal cycle. Once again I am repeating. After if you need defrosting, open the valve of the bypass line or hot gas. When it is opened, some gas going to condenser and some gas also going to evaporator through hot gas line. When hot gas is entering to the evaporator, the frost is melted. In this way, the frost is melted. This method is known as simple hot gas defrosting method. Now another is a automatic defrosting method. In automatic defrosting method, automatically it is defrosting. First you identify the system, now compressor. Okay, and this is the normal condenser, receiver. Okay, then it is going to a heat exchanger, and this way to normal expansion valve, and this is evaporator coil. See, this is the evaporator coil, and this is going to suction line, and another one more evaporator will be there, that is known as re-evaporator. So re-evaporator will be there and back to compressor. In this re-evaporator also one fan will be there, and in evaporator, normal evaporator also one fan will be there, and here additional one line. See, here additional one line will be provided. That line is having a solenoid valve. This solenoid valve is controlled by a timer, and this timer is controlling this fan A and fan B. Okay. So when you need defrosting, what happened? This timer on